4.1 Crunching the numbers. Explain the difference between a population and a sample. Data is information. It can be anything that you can measure, observe, or collect, like numbers, words, measurements, or observations. For example, your age, the temperature outside, a list of your favorite movies, or the number of likes on social media posts are all types of data. The word data is plural. So we say data are, not data is. The singular of data is datum. So data is plural. It's all the data. Datum is one piece of data. Statistics is the science of collecting, organizing, analyzing, and interpreting data. In simpler terms, it is ways to make sense of large amounts of information by finding patterns, trends, and relationships. For example, if you survey 100 people about their favorite ice cream flavor, statistics helps you understand what the most popular flavor is and why. A population consists of all subjects under study. A sample is a representative subgroup of a population. Compare and contrast the different sampling methods. There's different types of sampling methods. A random sampling occurs if a sample is drawn in such a way that each time an item is selected, each item has an equal chance of being drawn, kind of like a raffle. When a sample is obtained by selecting a random starting point and then selecting an nth item in population, this sample is called systematic sample. So like an assembly line where like you check every 10th car, or you check every 100th TV, or you check every 50th valve, like you do every so often you're going to check something. A cluster sample is sometimes referred to as an area sample because it is frequently applied on a geographical basis. So essentially the sampling consists of random selection of groups of units. Stratified sampling involves dividing the population by characteristics called stratifying factors such as gender, race, religion, or income. Convenience sampling uses data that are easily or readily obtained and can be extremely biased. So let's identify sampling techniques. Every 20th soup can coming off an assembly line is checked for defects. So because we see the every 20th is picked, we know that's going to be systematic sampling. So it's systematic sampling because it's every 20th they're doing something. A $50 gift certificate is given away at the annual bankers convention. Tickets are placed in a bin and the tickets are mixed up. Then the winning ticket is selected by a blindfolded person. So this is random because if you put a bunch of tickets and you mix them up in a bin and you pick them, everyone has the same equal chance of winning. So it's random sampling because each ticket has the same chance to win. Alright, C. Children in a large city are classified based on the neighborhood school they attend. A random sample of 5 schools is selected. All the children from each selected school are included in the sample. So this is actually cluster sampling because we're picking kids from a large city and in neighborhoods that the schools that they attend. So we're clustering our city into little clusters, little pockets to get cluster sampling. So it's a random geographical selection. We're clustering things together. All right, D. The first 50 people entering a zoo are asked if they support an increase in taxes to support a zoo expansion. So for D, that is actually convenience sampling. Think about it. If you're going to the zoo, you probably are a zoo person. You like going to the zoo, especially if you're the first 50 people going into the zoo. So you're more likely going to support an increase in taxes to support a zoo expansion. So because it's easy to obtain data, it is very biased because again, you're going to the zoo. So it's like if you're a beach person and you're there taking a survey at the beach and they ask, should we put lifeguards on the beach? You're probably going to say yes because you're a beach person. Be- so that is convenient because the people are already there. It's like if I go to a rock concert and if start asking people, how many of you like rock music? They're going to say they like rock music because they're at a rock concert. All right, last but not least, E. All registered vehicles in the state of California are classified according to the type: subcompact, compact, midsize, full-size, SUV, and truck. A random sample of vehicles from each category is given. So this is stratified sampling because we're actually setting the each category. We're not selecting geographical areas. We're not grouping people together. We're not grouping things together. We're categorizing subcompact, compact, midsize, full size, and so on. So the vehicles are separated into strata. That's what it's called when they're called groups of their on their classification. Organized data with frequency distributions. The data collected from a statistical study are called raw data. Raw data can be really difficult to interpret. In order to describe situations and draw conclusions, we need to organize the data in a meaningful way. Two methods that we will use are frequency distributions and stem and leaf plots. First, we'll study categorical frequency distributions, which are a way to organize data that are divided into distinct categories like age, your class setting in school, or conferences for college football teams. A health food store recorded the types of vitamin pills 35 customers purchased during a one-day sale. Construct a category frequency distribution for the data. So we have all the vitamins, C, 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 A, D, so those are all vitamin names. Now we're going to tally up to create a categorical frequency distribution. So we're just going to tally up how many people said C, or how many people bought A, how many people bought B, how many people bought vitamin E. So we have 5 types of vitamin. We have A, we have B, we have C, D, and E. All right, let's just count how many times we have A. Let's just count them all. So 1, 2, 3, 4, 5, 6. So 6 times. 6 times. You don't have to do tally marks. You can just write 6, but I'm writing tally marks. All right, for B, let's count how many times we have B. So 1, 2, 3, 4, 5. So 5B. All right, let's look how many times we had C. 1, 2, ooh, wrong color. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ooh, 12 of them. So 12 tally marks. All right, let's figure out how many times that they bought D. 1, 2, 3. Oh, just three. Just three people wanted vitamin D. And let's figure out how many people bought vitamin E. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 people bought vitamin E. And that is it. That's all it's asking you to do. Just organize your data. So we can see 6 people did A, 5 people bought B, 12 people bought C, 3 people bought D, 9 people bought E. That is much easier to look at than the chart on the top with all the check marks off on it. Another type of frequency distribution that can be constructed using numerical data is called a grouped frequency distribution. In a grouped frequency distribution, the numerical data are divided into classes. For example, if you gather data on the weights of people in your class, there's a decent chance that no two people have exactly the same weight. In that case, everyone would be in a separate category, and each category will have one weight in it. This, of course, would make the frequency distribution no more useful than the original list of raw data. So basically, it's not like the vitamins where you can only buy 5 vitamins. Weight, it's infinite if you really think about it. There's infinite numbers in between every number. So when you can't just say, okay, 6 people are 100 pounds, 5 people are 150 pounds, you can't do that. That's not how weight works. So we use something called classes. It would be reasonable to group people into weight ranges like 100 to 119 pounds, 120 to 139 pounds, and so forth. In the 100 to 119 pound class, we call 100 the lower limit and 119 the upper limit. So rules for data grouped by classes. The class should be the same width. The classes should not overlap. Each piece of data should belong to only one class. Often suggested that there be 5 to 12 classes. Your lower class limit is on the left side, your upper class limit is on the right side. Your midpoint of a class is found by dividing or by adding the lower and upper class limits and dividing the sum by 2. Constructing a grouped frequency distribution. Decide how many classes you want and to divide the data into. Between 5 and 15 is acceptable, depending on the number of data values in the set. That is up to you. I know I said 5 to 15 here, and then I said 5 to 12 there. I'm going to say 6 to 8 in the next one. It's really up to you. You determine the width of each class. Class width is largest data value minus smallest data value in the number of classes. Then you round this value up to the next biggest whole number. Use the lowest number in the data set or a nice number lower than the number of the lower limit for the first class. Add the class width to the first lower class limit to get the second class limit. Do this for all classes. Find the upper class limit for each class by subtracting 1 from each lower class limit. Tally up the number of data values in each class, then put the frequency next to each class in a table. That sounds, I know, when I read that, you're probably like, you're not understanding anything. All I hear is class, 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 class. That's okay. Let me break this down for us. So building a grouped frequency distribution, we're going to organize the record high temperature data from the table. So Alabama all the way to Wyoming, all the record high temperatures that they've ever seen. The highest temperature I have ever been in is 118 degrees. My gosh, was that horrible. I spent summers in Arizona. Okay, so we need to decide how many classes. That is the very first step. So to do that, let's look at our lowest temperature. So if we look at our lowest temperature, and if you think about it, it's going to be somewhere really cold, like Alaska. Alaska, the lowest, highest temperature they had is 100 degrees. So the lowest temperature in this chart is 100 degrees. Now let's look for the highest. So the highest temperature is probably going to be somewhere where there's a desert, like California or Arizona or New Mexico. So Arizona is 128, California is 134, Iowa 118, Kansas 121. All right, it looks like California wins it, 134 degrees. So that is our highest temperature and our lowest temperature. That's a span of 34. So there's 34 in between them. And if you think about it, we have 50 data pieces because we have 50 states. So we have 50 data pieces with a 34 span. I'm going to say let's use 7 classes. It's up to you. This is 100% up to you. You can use 10 classes. You can use 5 classes. You can use 6 classes, 8 classes. That is 100% up to you. I can't tell you what to decide. I'm going to use 7 because 50 divided by 7, it's almost 5. It gives me about 5 degrees per class. I don't know. I just like that number. It works best for me. So now we're going to find the class width. So basically it's like the scale of like 100 to 110 or 100 to 103. We're finding that scale. So our class width is our largest value minus our smallest value. And then we're going to divide that by how many classes we want. So our largest value is 134. Our smallest value is 100. And we said, well, I said I want 7 classes. Totally up to me. So that leaves us with about 4.9. So it said to round to the nearest whole number. So 5. 5 is our nearest number. So that's our class width is 5. So that means we're going to start at our lowest number and count to 5, and then that's a class. And then the next class, we're going to count to 5, and so on. Don't worry, I got you. So here's our little chart, class tally marks frequency. So our class starts at the lowest number. Luckily, our lowest temperature is 100. That's a nice number. So let's say the lowest temp was like 98 degrees. I would probably start my class width at 95. That's what a nice number means. It's up to you though. So our first class starts at 100 because that's our lowest number. So we start at 100. So 100, that's 1. 101, that's 2. 102, that's 3. 103, that's 4. 104, that's 5. I literally am counting on my fingers right now. So 100 to 104, that's 5. Okay, so the next one, the next number is 105. Now we're going to count 5 more. So 105, that's 1. 106, that's 2. 107, that's 3. 108, that's 4. 109, that's 5. So this goes to 109. All right, so our next number is 110. So we count 110 is 1, 111 is 2, 112 is 3, 113 is 4, 114 is 5. So this goes to 110 to 114. So then we have 115 to 119, 120 to 124, 125 to 129, and 130 to 135. I know to stop there because the highest temperature is 134, so I don't need to keep going. I stop right there. So we have actually a lower class and an upper class. So your lower class, those are the left side of your classes. So that's 100, 105, 110, 115, 120, 125, and 130. Those are your lower classes. Our upper classes are the right side. So that'll be 104, 109, 114, 119, 124, 129, 135. Sorry, 134. I said 135 out loud. That's why I wrote that. 134. All right, so now that we got that, we are going to count how many temperatures we have in each range. So 100 to 104, let's count how many we have. Alaska, Rhode Island, so 3. Alright, let's count how many are 105 to 109. 8. Now let's count how many are between 110 and 114. So Alabama, so 16. 16. Alright, let's do 115 to 119. So that's 13. Alright, next we have 120 to 124. Alright, let's do 125 to 129. So only 2. Alright, last but not least, we have 130 to 134, and the only one we have left is California. Another way to organize data is to use a stem and leaf plot, sometimes called a stem plot. Each data value or number is separated into 2 parts. For a 2-digit number such as 53, the tens digit 5 is called the stem, and the ones digit 3 is called the leaf. For the number 72, the stem is 7 and the leaf is 2. For a 3-digit number, say 138, the first 2 digits 13 are used as the stem, and the third digit 8 is used as the leaf. For values rounded to the tens place, like 8.4, you can use the value to the left for the decimal place as the stem and the tens place as a leaf. As in our next example, in any case, the very first digit is used as the leaf, and what comes before this is the stem. Note that we'll include a key with our plot that clarifies what the stem and leaves represent. The online homework for this requires that the leaves are ordered from smallest to biggest, so we're actually going to have to organize these by numbers for your homework. Alright, so we have um, all our states, just different values again. So let's look at all of the first digits. So if we look at all of the first digits, we have 3, 6, 4, 3, 4, 3, 3, 3, 3, 2, 4, 3, 4. So you can see all the first numbers. So all the first digits are from 2 to 6. Those are called our stems. So a stem and leaf plot, we have our stems, and then we have our leaves. So our stems are from 2 to 6. So 2, 3, 4, 5, 6. And now we're going to look at all of our numbers that start with the 2 and then write down the number afterwards. But we have to write them in order. So let's bring out all the ones with 2. I'm going to really show them. We're going to circle them. So Hawaii, Idaho, Iowa, Nebraska, New Hampshire, North Dakota, Vermont, Virginia. So we have all of our things with 2. So we have 2.7, 2.8, 2.4, 2.8, 2.4, 2.5, 2.5, 2.8. So our smallest ones are 2.4. We have two 2.4s. So we look at 2.4, we write the second number, 4. So that counts for this one. Then we have another one, New Hampshire. So 4. All right, then we just keep going. Okay, we have 2.5, North Dakota. And we have another 2.5 of Vermont. And then we have a 2.7 for Hawaii. We have three 2.8s. So 1, 2, 3. So we're going to write 3 8s. Or just 2 8s, just 2 8s. No, there's 3. There's 3 there. Never mind. Don't listen to me. And then we have a 9. Alright, now we're going to do the same things with 3s. So let's look at everything that has a 3. Alright, the ones circled in orange are all the ones with 3. So if we look at all the ones with 3, the smallest ones we have are just 3. So 3 is actually 3.0. So we have 2 of those. Alright, then we have 3.1 and another 3.1. So we have 2 3.1s. So that means we need 2 ones. Alright, let's see if we have any 3.2s. We do. We have 3 3.2s. Let's see if we have any 3.3s. We do. We only have one 3.3. And then 3.4, we have 2 3.4s. 3.5s, we have 5 3.5s. Sorry, 3 3.5s. 3 3.5s. Sorry about that. Alright, 3.6s, we have no 3.6s. 3.7, we have 3 3.7s. And then 3.8s, we have 5, 6. We have 6 3.8s. 3.9s, we only have one 3.9. Alright, now we move on to our 4s. So anything with the 4 in it. So 4.9, 4.2, 4.3. Alright, so let's start at 4. So we do have 4s. Remember, 4 or 3, that just means 4.0. So we have 4 just normal 4s. So 1, 2, 3, 4. Alright, let's see if we have any 4.1s. We do. We only have one 4.1. 4.2, we have two 4.2s. 4.3, we only have two 4.3s. 4.4s, we only have one 4.4. 4.5, we have one 4.5. 4.7s, we have two of them. We don't have any 4.8s. 4.9s, we have two 4.9s. Alright, now let's move on to the 5s. So for 5s, we have only two that start with the 5. Right there and right there. So we have 5.1 and 5.2. And for our 6s, we only have one with the 6, and that was 6.5. So the little part of will include a key. That's what we're going to do. We're going to actually tell the people, the readers, how to write this. So 6 line 5, that actually means 6.5. So 2, 4, that's 2.4. 3, 0, that's 3.0. 4, 0, that's 4.0, and so on.